Welcome to BDB Platform 8.0. Enhancing students' academic performance using AI. With the help of artificial intelligence, AI, science teachers can analyze data from previous student records to make informed predictions about their future academic performance. This information can help teachers identify which students may require additional support, enabling them to create personalized study plans to improve their proficiency. By doing so, AI can significantly enhance learning outcomes and lead to better grades for students. Benefits: saves time and resources by empowering teachers to independently identify students who need extra help. Helps to improve overall student performance by creating personalized study plans tailored to the needs of individual students. Allows teachers to provide proactive support and intervention before students fall too far behind, improving the likelihood of success. Encourages data-driven decision-making in the classroom, leading to better educational outcomes for all students. Ease of use. The process is straightforward and does not require advanced technical skills, only access to previous student records and basic data analysis abilities. Teachers can adjust their teaching methods based on student progress, providing personalized support to improve proficiency. By identifying at-risk students early, teachers can help prevent larger problems down the line, leading to a smoother learning experience for everyone involved. In this video, we will create this work step by step. First step, data upload. Second step, data science AutoML experiments. Third step, create pipeline to automate the complete workflow for new data file. Fourth steps, create a data store. Fifth step, self-service dashboard creation and natural language search and perform data exploration. Now let's first look at the data. Data files contain student ID, grade ID, term ID, school year, teacher ID, course, student gender, student demographics, previous semester 1 and semester 2 proficiency details, and another file contains score details. Let's go to the BDB platform and start the workflow. This is the home screen of the platform. Navigate to Data Center. Go to Sandbox. Create the new sandbox, click on the plus icon on top right corner. Provide a sandbox name and description. Choose File and click Upload. Great! File uploaded successfully. Now let's create another new sandbox for other file, click on the plus icon on top right corner. Provide a sandbox name and description. Choose File and click Upload. Nice! File uploaded successfully. Now let's navigate to Data Science Lab by clicking on the grid menu icon and selecting the DS Lab icon. Create a new project. Provide a project name, project description, select the algorithms, select environment, and resource allocation and idle shutdown, and save the project. Our project is created and let's activate it. Select the project and go the dataset and add the sandbox files which we uploaded in previous step. Select sandbox in the data source and it will list down the sandbox files. Select both the sandbox and click on Add button. Now we can perform AutoML on these data. Click on the third icon to create AutoML experiment. Give an experiment name, description, and select the target column. In this experiment we are creating for predicting the score using regression algorithm. AutoML experiment is started. Let's create another AutoML experiment. Meanwhile, regression experiment will get executed in the background. Select Dataset, navigate to Other Sandbox and select the third icon to create the experiment. Give an experiment name, description, and select the target column. In this experiment we are creating for predicting the proficiency level using classification algorithm. AutoML experiment is started. While both experiments will take some time to complete the processing and give the output, let's automate this flow so that next semester we just need to add the data file and flow will execute automatically. Navigate to Data Pipeline plugin to create the pipeline. Create a new pipeline. Provide a name and description and select the required resource allocation option and save it. We are ready to create the pipeline. In the workflow, our new data file will be uploaded to the SFTP location. So, let's select the SFTP monitoring components and configure the meta information. As the pipeline is event-based, so create an event and map it with the SFTP component. As we will get two data files, let's use the file splitter component so that we can process both the data files and run classification and regression algorithms in parallel. The file splitter component will help to split the file based on the name as shown in this video. Configure the meta information of the file splitter component. Now let's add two more events and configure it with file splitter components. One for classification and another for regression. Configure the file splitter component and select two outputs. Rename the event as regression and save it. Rename the event component to classification and save it. In file splitter component, add the file names. Now we will add the SFTP stream reader and configure the meta information. We must repeat the same for both the flows. Now let's create two more events and configure it with SFTP stream reader components. Now we will add the automl runner component. We will configure the automl component after publishing the model from Data Science Lab. Create two more events and configure it with AutoML components. Let's write the output of the automl to the ClickHouse database. Configure the ClickHouse write meta information and save the pipeline. Let's go to the Data Science Lab and check the status of the automl experiments. Fantastic! Both the automl experiment are completed and we can view the reports. Let's view the classification model report. It shows recommended model with model score and other details. Click on the Models tab. It will showcase top 3 models with its best accuracy score and fit time and option to view the explanation. Let's view the explanation for first model. It showcases the model summary, model explainer and dataset explainer. In model explainer it shows features importance, classification stats, individual predictions, what-if analysis and feature dependence. These details are very helpful for data scientists to finalize the model which can be deployed on the production environment. Let's register the recommended model so we can configure it in the pipeline. Navigate to the Model tab. Select the All in the filter to get the list of all available models. Click on the Expand Models to get the list of all 3 models and select the recommended model, and register it by clicking on the last icon. Repeat the same step to register another model. Let's navigate back to the pipeline and configure these models in the pipeline. Great! Our data pipeline is almost ready. Now it's time to activate the pipeline. We can monitor the logs. It will showcase the status of each component. Once all the components are up, we will upload the data to the SFTP location. Drag and drop the new data files to the SFTP location. Now both the files are uploaded successfully. Let's check the pipeline if it has started processing. Excellent! The pipeline picked up the data file from SFTP location and started the processing so fast. You can both files in the preview. Now let's see how both files are split into different workflow in pipeline. Wow! Classification file reached to classification workflow and regression file reached to regression workflow. We can preview the data in the event after SFTP Stream Reader. We can preview the output of the autumn model. New prediction column is added in the data. Finally, the data is written to the ClickHouse successfully. Now it's time to do the data exploration on these data. Navigate to Data Center. Let's create 2 data store. Go to Data Connector. Select your data connector. Click plus icon next to edit icon and select New Data Store. Provide a data store name and write simple select star from the table. Enable scheduler and click Next. Platform will automatically identify the measure and dimension, and we can change it based on the required. In this workflow, we shall convert grade ID, student ID, teacher ID, term ID to dimension and click Next. Currently we don't want to define hierarchy. Click Next. We are not running any batch query in this workflow, click Next. No data restriction in this workflow, click Next. Schedule the refresh based on the required frequency and click Finish. Similarly, let's create another data store. We can view the data store creation status notification. Now let's do the data exploration using Business Story. Click on the plus icon on the top right corner and select Create New Story. Provide a name to the story. Select the existing data store which we created. Select Measure and Dimension and start creating the story. Select Student ID, give proper name, select the font color and save it. It will give total student KPI tile. Next select Student ID, give a proper name, exclude it from global filter, and apply filter on student gender, male. This will give a KPI tile for total male students. Follow the same steps to create KPI tile for total female students. Drag and drop student gender and prediction. Change the aggregation type to mean. This will create score prediction by gender view. Select the interaction and enable different view to drill. Drag and drop student passport and prediction. Change the aggregation type to mean. This will create a view for predicted score by demographics using the output of regression algorithm. Select the interaction and enable different view to drill. Similarly, let's create different views for proficiency prediction for students using the output of the classification algorithm. Bottom 10 students based on the predicted score. Predicted score comparison with previous semester's score. Let's explore the data using natural language search. By analyzing student data, BDB Platform can identify areas where each student needs additional support or challenge. This allows teachers to create customized lesson plans that cater to each student's unique learning needs. Not only does BDB Platform help teachers save time and effort, but it also allows them to track student progress in real time, enabling them to adjust their teaching strategies accordingly. Overall, BDB Platform is a game changer for educators who want to empower their students and enhance their academic performance. We hope you enjoyed learning about BDB Platform and its capabilities. Thank you for watching.